My name is David Woodard. I'm an engineer with Eurotech, focusing on our IoT opportunities, mainly in software, but kind of branches over into our hardware products as well. So I'm here today to talk about a sort of new paradigm in IoT application development that's based on visual programming, like Dataflow model programming. Just very few people in the room, so we'll make this maybe interactive. How many people here have actually heard of Eclipse Kura or have used it? Perfect, so I can skip those slides. So today we're going to be mainly focused on industrial IoT. It's kind of why this product came to be, but it's not, it's not a requirement to use this. It's more of a general methodology that can be used for any IoT solution. So as I said, this came about because we do a lot of business with industrial customers, and you'll hear things like IoT and IoT or Industry 4.0, and this is kind of a roadmap of what we're talking about, right? So it's the generations of how we came to be where we are in industrialization. So we started with just plain mechanization through steam and water, those kinds of things. We moved from that to mass production, so repeatability. Start getting some of the human error out of production. Then came robotics. So most factory floors now you'll see all kinds of robots and smart devices doing some of the dangerous and repetitive jobs in these scenarios. Which brings us to 4.0, which we bring connectivity to these into these systems, and that is at the heart of an IoT solution. So from our standpoint, when we look at IoT products and IoT solutions on the market, there's some serious challenges. Fragmentation, so lots of different protocols, lots of different disparate devices that are trying to get connected. You see complexity, like some of these systems can be incredibly complex. And lock-in, which is one of the worst. So some vendors will come and say, we have an IoT solution as long as you use it from the ground up. And they really interoperate with other vendors, which can cause limitations in what you can accomplish in your solution. So for us, we broke down the complexity into tiers, and this is an architecture you probably have seen many times if you're in the IoT field, where at the bottom layer you have your sensors or whatever it is you're trying to measure. Your PLC, your Modbus device, whatever it may be at the bottom, and here's where you're going to put some type of intelligent gateway, some type of intelligent product that can speak all these different protocols, but also provide connectivity, upward. But it requires more than that because you also need device management down at this layer. You need some intelligence to run your applications, possibly analytics down here, so you're not flooding your cellular connection with data that you don't need. Then if we go up one layer, like your integration platform, so this would be your cloud backend. This is incredibly important for doing your device management, your software rollouts, aggregating your data. And above that is your actual application, like what is it you want to present to your user base, be it your engineers or your customers. But for today, we're focused on the bottom layer. Since everybody here today at least had heard of Kura, I'll be brief on this, but what Kura is an OSGi Java framework meant to run on one of these intelligent gateways. It's meant to run on most any kind of hardware. It's can run on pretty small devices. I know the original Raspberry Zero ran fine on that, so it doesn't have to be really industrial hardware. It can be very simple open type hardware. But it can also run on industrial hardware. It doesn't really matter. It's Java based, so as long as you can run the JVM, you're okay. On top of that is Linux. Right now we require Linux to run the framework. We're working on Windows, but it's been a little bit tricky. And then of course you have Java, OSGi, and on top of that's where Kura sits. And the key point here, in the next slide I'll talk about it more, is your application, what it is that you have to do becomes very small because the framework is taking care of a lot of the connectivity, a lot of the protocol management, and those kinds of things. And this is why the reason we went with Java and OSGi is for that reason. So we could be somewhat hardware agnostic. So the same framework runs on the ARM processors. It does an Intel-based processor. OSGi gives us flexibility in modularizing the framework. So if you need to update your application, you're only updating that piece of the framework. You're not having to do massive software rollouts and updates. Okay, so more to the point. So I do a lot of customer-facing opportunities, and this is the sort of train of thought I see all the time, is I go in and say, yes, we can connect your PLC to the cloud with this gateway, and people get very excited about that. But then the next thing they say is, oh no, I have to learn Java and OSGi. And when you're in an environment where people are lifelong embedded C programmers or ladder logic guys, this is a real stumbling block for them. Not because they can't learn it, but they're already working long hours, and that what is their incentive to learn this new language and this new framework. So that's where we kind of came up with this notion of abstracting away that Java OSGi learning curve and put it in a Dataflow programming model. So it's very simple. It's very similar to what you've probably seen in Node-RED. It's the drag and drop connecting components. It's a completely different approach to it, so we're not trying to compete with Node-RED anyway. This is a wrapper around an OSGi specification. So there's a thing in OSGi called wire admin that does message routing within the framework, and we just put a visual layer on top of that. So what we're calling it is Kura wires. So it is, like I said, it's this wrapper around this existing specification. We put a canvas into the UI, and if you've seen the Kura UI, then you'll know what I'm talking about. If not, we'll have a short demo that we can discuss it. But it just provides the ability, to connect these devices without writing any Java code, right? So it removes that barrier of people being scared to get started in something that they don't know little, or they know little or nothing about. But it's also extensible. So if you are a Java person, if you are an OSGi person, you can still use this framework. So that's why I was saying this is not just about industrial IoT. This is all Java code, Java standards. You can extend, add your own assets and components, and wire up your own application. Okay, so with that, I'm just going to kind of show you what we've done. Okay, so this is the Kura web UI, and again, I don't know if you've used this or not, but this is the administrative page of the gateway. So if you're physically connected to the gateway over some TCP connection, this is the UI you get, and from here you can program the gateway, install applications, and do those kinds of things. So what we've added is this canvas, which is the Kura wires. So what I've got here is, to save time, is I went ahead and put together a pretty small demo with some of the components we have available. So I have, at the top left here, I just have a timer, which is just right now it's set to be just every, 10 seconds, it's going to go and tell the other components to do something. This can be set up as a cron type timer as well. I have a Modbus device, so this is the actual driver, the actual service that's going to communicate with this downstream Modbus device. And right now, what we have is Modbus and OPC-UA, but we're working right now on Siemens S7, and we're going to keep adding more to the store. I have a publisher, so this is just going to publish whatever comes out of my Modbus read to the cloud. I have a database, so an on-device database that's going to also store this information. And then I can filter my database, so just using standard SQL, as you can see down here. Standard SQL queries, I can actually query my database and start putting some intelligence into my graph, so I can start looking for values, looking for alerts, and then maybe sending something to the cloud based on that, instead of just sending all data. And then over here is just a simple logger, so something just to log to the standard Log4j Java logger. Okay, so what's it doing? So what I have is a Modbus simulator. So this is a pretty handy device. It's just simulating Modbus over TCP. So it's just sending data, or it's just holding data in a register that I can read from my gateway. And this is Eurotech's cloud. This is not dependent on Eurotech's cloud. I'm just using this because it was easiest for me to connect to. But this is where the data is aggregating. So I can look at so I can look at the data as it's coming across. So if I go to my Modbus simulator and just change the value in one of the registers over a couple of seconds, and wait for the reads to kick in, you'll see it shows up live in the cloud. So pretty trivial demo as far as what it's doing, but the key point here is that I did all that really with 3 components. I have some others on here, but just the timer, the Modbus driver, and the publisher is really all I needed to connect the Modbus device to a cloud backend. And I can tell you that that is a very nice thing to have for customers. You show them this and they get very excited because there was no Java. I didn't have to do any programming, put things on the canvas, and it's going. Okay, so that's where we are right now. So we just released our milestone release of Kura. It's Kura 3.0 milestone. It's available now. You can go to our website and find it. You can download it and try it out for yourself on a Raspberry Pi or whatever your hardware is. The official release should be coming late April is what we're planning. Right now we're in the process of sort of beefing up the back end to make sure it's really production ready. So we're changing some of the API layer things, but the canvas will remain mostly the same. So that's coming end of April. If you're interested, that's the GitHub site, the mailing list, which is monitored pretty frequently. So if you have questions, post there. You would definitely get responses. And the Twitter handle, which is not as much activity as it probably should have. But, so yeah, so that's pretty much everything I have. If you have any questions, I know we have some time and a small crowd, so I'm happy to answer any questions or show anything else in the simulator. So any questions? Yes, please.
We use ontologies of semantic technologies to map the different signal coming from different devices or something?
You mean from the different nodes on the graph, or from the actual device at the hardware level? So I can go back and show you. So as far as connecting the Modbus or the gateway to the Modbus, that requires a driver of some sort. Like you have to have something that speaks Modbus or something that speaks OPC-UA. So we have those available in the Eclipse Marketplace. So if you go to the Eclipse Marketplace, you'll see under IoT, Eclipse Kura, you'll see things like Modbus driver for Eclipse Kura or OPC-UA component. So those are the drivers. That's what creates the connectivity down to whatever you're connecting to. And then as far as between the devices, the actual nodes are completely agnostic from each other. So you can connect any 2 nodes together. It doesn't matter. The node just has to know how to respond to the record that's coming in. But I can take any component, put it on the graph, and wire them together, and it's completely fine. Whether or not that makes sense, that's a different story. And if you wanted to implement your own wire component or your own asset, that would just be something that you would have to think about as you get this data object coming in, you have to be able to process it and do something on it. Does that answer your question? Okay.
So
yes?
The wires
Right, so again, this is not Node-RED. So it's a lot simpler than Node-RED. To do what you want to do, probably the easiest way is just to create your own wire component and then have the Java code do what you want. You know, I can think, you know, one of the things we really want from the community, again, this is all open source and it's only successful if the community gets involved, is we want people to contribute to the marketplace, to add your own wire components or your own assets. So I could see something that did exactly that, is where it was just a kind of a dummy wire component where you could paste in whatever, you know, something that processes, you know, JSON or whatever it might be, you know, because any, you know, like all these components have, let me get a good one, like these sort of input dialogues that you can define. So this could be just a plain editor to which you could enter something and have it process. And in fact, that's what we do with the filter. You know, we just have an input for, you know, SQL query strings. So yeah, so that the list on the right will grow over time. Right now, we just have bare minimum components to do things like this, but we want to see that grow over time so we can have more functionality in the graph, more possibly like analytics and those kinds of things that you can plug into the graph.
Does this one depend on the other open source projects? Because I know the visual programming, there are already a lot of existing open source projects that they have. So this is developed from scratch, or you use some other project?
So this is mostly, like I said, this is mostly just based off of an OSGi specification component. So that was already in the container that we were running on. The only open source piece that we used was for the JavaScript. So it's a thing called Joint.js. So it's just a graphing library that allows us to create these boxes and wire them together. And the neat thing is all of this is just a JSON. This is just one giant JSON object. So down the road, you know, we want to be able to make it so you can download this, you could upload it into another, you know, instance of Joint.js running. You know, we have our cloud backend. We're in the process of open sourcing that as well. So we think it'd be really cool to have this replicated like in the cloud, so you could do this remotely as well. So, but that's really Joint.js is really the only other open source sort of technology involved, but it's just a JavaScript library. Okay, anything else? Well, I'll call that good. So I'll wrap it up there. Thank you for coming, and I'll be around. So if you guys want to talk about it, I'm happy to answer questions. Okay, thank you.